Welcome to the video lecture series on formal languages and automata theory. In today's video lecture, we'll be learning about an example related to Turing machine. This is Dr.K.N.Sivabalan. And today's video lecture, we'll be learning about the way of designing a Turing machine for a specific language pattern called as a to the power of n, b to the power of n, where n minimum takes a value of 1 and maximum it can take infinite values. So in this case, we have an algorithm to design this Turing machine. When we encounter A, we will replace the A by X and move towards the right until a matching B is found. Once a matching B is encountered, we replace it by Y and move towards the left. And we will be keeping on moving in the left till we encounter X now. Once we encounter X, we again move on the right and repeatedly we do the process. A will be replaced by X and then we again find B to replace it by Y. So this process will be repeated till all the symbols are getting replaced in the tape drive. Now once if when we move on the left after X is found, when we move on the right when X is found, if there is no other symbols to replace, suppose if only X or Y is found, that means almost everything is getting replaced. So this is the algorithm for a to the power of n and b to the power of n. So let us take an example for designing a Turing machine. First we will actually make a tracing for this Turing machine. Now in this case I have taken 3 A's and 3 B's, where this triple A and triple E's are flanked by blank symbol here. Now we will initially start with a state called as Q0. In Q0 when A is the input, so we will replace that A by X and we will move on the right. When we move on the right, we stay in the same state called as Q1. So Q0 to Q1 we make a move. In Q1, when we keep on reading A or A, we will be staying in Q1 itself. So Q1 we replace A by A, move on the right. Again we stand on Q1. Again A is there. So we will be again replacing A by A, move on the right. When we move on the right, now B is there. So B is a new symbol. So B has to be replaced by Y and we will move on the left. So B will be replaced by Y and we will be going to a state called as Q2 and we will be moving on the left. So when we move on the left, we see a state called as input called as A. So we have to keep on moving in the left until we encounter X. So now A is replaced by A, we will be staying in the same state called as Q2. Again A is replaced by A, we will be staying on the same state called as Q2. Now when we see X, we move on the left and we move to the state called as Q0. Okay. Now when we read X now, X is replaced by X, we move on the right now. So and A is there. So when A is found, A is replaced by X and we move on the right now. So again when we move on the right, we have A now. So A is again replaced by A, stand in the state called as Q1. And in Q1 when Y is encountered, now Y is replaced by Y, we will be moving on the right. So when B is encountered, so we will be transferring that into B will be converted by Y and we will be moving on the left now. So we move on the left now. So again Y is there. We will be keeping on moving in the left. So until we encounter X. Okay. Still we move on the left. Now when X is encountered, we will be replacing X by X and move on the right. So when we move on the right, now we have a state called as A is replaced again by X, move on the right. Okay. Move on the right, we go to a state called as Y. At Y, we actually replace Y by Y in Q1. Again we move on the right, Y is replaced by Y in Q1. And again now, when we move on the right, we see a symbol called as B. B should be replaced by Y and move on the left. So in Q1, so we will be keeping on moving in the left until we see a state called as X. When X is found, okay, when X is found, now we will be moving on in the right till we encounter a blank symbol to halt the process. So we move on the right, Y is there, again we move on the right, again Y is there, Again we move on the right, y is there, and when we see a blank space, okay, now we move on the right, but we won't move on the right because we will be stopping that, we will halt the process. Okay, so we'll accept it, we go to the state called as Q4. So this is the way of designing the Turing machine for the specific pattern. So the state diagram is as follows. So you can see here we have an initial state called as Q0 and Q4 is called as a final state. Now all these respective transitions are made in the diagram. So that in that we have an animated illustration in the previous slides, and that has been depicted as a state diagram here. And we'll now take up a simulation. For in this case I have taken 2 A's and 2 B's. Now initially we have Q0 as an initial state. So in Q0 when A is applied, that means A is replaced by X, and we will move on the right and state will be changed as Q1. So it will be changed as Q1. Now in Q1 when A is applied, we will be staying in the same state called as Q1 and move on the right. So Q1, now in Q1 when B is applied, B should be replaced by Y and move on the left side, and we go to a state called as Q2. Now in Q2 when A is applied, we will be replacing A by A, move on the left. So replaced by A, move on the left, we will be standing in the same state called as Q2. So in Q2, when X is an input, we will be transferring to the state called as right side, and we go to a state called as Q0. Okay, so Q0 will be moving on the right. In Q0 when A is applied, now this is a one iterative process has been completed. This is again the second iterative process. So in Q0 when A is applied, so A will be replaced by A in X by X and move on the right side. So state will be changed from Q0 to Q1. In Q1 when Y is applied, we will be replacing Y by Y, move on the right. In Q1 when B is applied, we will be replacing B by Y and move on the left. So when Q2 X is applied, it means that there is no other process here. So now we go to a state called as Q0. In Q0 when Y is applied, now obviously we have moving towards a final state. So we go to a state called as Q3. Again when Y is applied, we go to a state called as Q3, move on the right. Now in Q3 when B is applied, obviously we will halt it now because blank symbol has been encountered. We will halt it. So we will halt it there. So this is the way of actually designing a Turing machine for a specific language pattern called as A to the power of n and B to the power of n. So thanks for watching the video. Have a good day.